two pieces of information uniquely determines a plane. Okay, a point on the plane and a vector perpendicular to the plane or normal to the plane, the same thing. So because the plane can be uniquely determined using the two pieces of information, the equation of the plane is also determined. Okay, now we talk about the rectangular coordinate plane. So by that we mean in the plane there are equipped a rectangular coordinate system. Now let's say the origin is here. Now let's recall the setup. X-axis is outward, right? And the y-axis is rightward. And then you also have z-axis, which is upward. Illustration only. Okay. In that setup, each point in the space can be represented by the coordinates, right? X coordinate, y coordinate, and z coordinate. I give you a point, so now let's say the x coordinate is I forgot the notation. I think it's x0. Okay. X coordinate is x0 or x0, however you say it. Okay. X0, y0, z0. And a vector in the plane has three components, right? So now let's say n is a vector perpendicular to the plane. In this context, we call it normal to the plane as a normal, perpendicular, normal to the plane. Okay. Each vector in space has three components. So now let's say the first component is A, the second component is B, the third component is C. Okay. If you know a point on the plane, if you know a vector normal to the plane, and then the conclusion says we can write the equation of the plane. So very shortly so later on, if we have time, I'm going to tell you why the formula is true. But now concentrate on how to use the formula. How to use the formula, okay? Again, the equation of the plane, if you look at the unit 1, the equation of the plane, now let's try to memorize together. It's given by the following. Okay, A is the first component of the normal vector. X0 is the x coordinate of the point on the plane. Okay, three terms on the left hand side. A times x minus x0. Okay, and then plus b times y minus y0, and then plus c times z minus z0, right? On the right hand side you have 0. You have the number 0. Okay. This will determine an equation of the plane. I don't think we have an official name saying the form. So now suppose you want, we could call it a point normal vector form. So comparable to what you learned in high school, you learned point slope form, right? You learned the slope intercept form, you learned many forms. It's not official name, but we could call it point normal vector form. By that we mean if you are given a point on the plane, if you have a normal vector to the plane, and then we can get the equation of the plane. The equation is given by that equation. Okay. The general thing is probably a little abstract to some of you guys, but I'm going to show you a particular question showing you the meaning. In this formula, A, B, and C are numbers. X0, X0, Y0, Z0 are numbers. So eventually you have a linear equation of three unknowns, X, Y, and Z. Okay. I will make up a question to show you what I mean. Okay. What I mentioned is the stuff in the theorem. Okay. Again, you are given a normal vector, so you know the components of the vector, you know the coordinates of the point, and then you can get the equation of the plane. I will make up a very straightforward question to illustrate the formula. Okay. Now, for example, if I want you to find the equation of the plane, to use the conclusion, you need two things. You need a point, you need a vector perpendicular to the plane, right? Passing through a point. Passing through the point. So now let me try to use P to denote the point. Passing through the point P. A point in space has three coordinates. Once again, okay. Whatever number you want. So now let's say 1, 2, 3. Okay. You can imagine the location of the point in space, in the rectangular coordinates space. I mean, okay. And find the equation of the plane passing through the point, and with a normal vector. The standard notation for a normal vector is kind of n for normal. Okay, a vector in space has three components. So now let's say the three components. So whatever number you want. So now let's say 4, 5, 6. Again, try to imagine the direction of the vector and how long. But okay, we just need one single point and one normal vector. Okay. Straightforward. Okay, now you look at the conclusion and try to compare with the notations. I think P, a given point, a point on the plane. In the formula, the notations are x naught, y naught, z naught, right? So x naught value is 1 in this case, in this particular case. Y naught value is 2, z naught value is 3, right? And then 4 is the a value, right? We use a, b, c to denote the components in the normal vector. So 4 is the a value. 5 is the b value. 6 is c value, right? Now all you need is to plug all the numbers in, and then we can have the answer, right? Solution. So it's very straightforward. Okay. In the general formula, you have a. Okay, you have a. The first term is a times x minus x0. X. Okay. So you have something like 4 times x minus 1, right? The first term, and then the second term is 5 times y minus 2, and then plus 6 times z minus 3, right, is equal to 0. Okay. In the future, if I'm looking for an equation of a plane, that form is perfectly okay. I'm trying to say you do not have to convert the equation to any other form. But I think there's a term for the general form, the standard form. So whatever form. Okay. If I want you to convert the equation to now let's say the standard form, you could do something like this. Okay, you could do something like this. I just want to convince you it's indeed a linear equation of three unknowns. Okay, you multiply them out. Multiply them out. I mean, okay, you have 4x minus 4. Okay, and then plus 5y minus 10, right? And then plus 6z minus, I believe, 18 equals 0. Now the standard form or the general form, in most cases I do not care about term that much, but the general form or the standard form is going to be something like this: 4x and then plus 5y, right? And then plus 6z. The standard form is you leave all the terms involving unknowns on one side of the equation. In most cases, the left hand side. The right hand side, I'm not sure what the right hand side is. So anybody want to tell me the right hand side? 14 plus 18, I think you have 32. Do you? You have 32, right? Sure, thank you. Cool. Again, in most cases, if you see a question like that, I'm looking for an equation. The first line is perfect as the final answer. So because if you read the answer that way, I can see a point on the line. I can see a normal vector. Okay. It's also okay to convert the final form to the standard form. Okay. In most cases, you do not have to. Okay. But the last form is called the standard form.
And what do you call the first form, sorry?
We do not have a name for that. I was trying to call it the point normal vector form, but that's not the standard term. It doesn't matter. We do not have a name for that. Okay. Okay. I'm going to make some more comments. Okay. In many cases, an equation of a plane is given using some other forms, like the standard form. As long as you have the standard form, and then it's easy to identify a vector perpendicular to the plane. Or we can say it's easy to identify a vector normal to the plane. I'm going to make some conclusion on the next slide. Okay. It's also on the notes, but I still want to write it down. Okay. Okay. So maybe some comments or notes. So note. Okay. A note. You know, a linear equation of three unknowns. The graph of a linear equation of three unknowns is always a plane. Okay. On the other way is also true. Okay. If you are given a linear equation of three unknowns, and then the graph is a plane. The note I'm trying to write is the following. Okay. Now suppose you are given a linear equation of three unknowns. We also call it given a plane. So because the graph of a linear equation of three unknowns is a plane. On the other hand, a plane represents a linear equation of three unknowns. It's always true actually. Okay. Given a plane, so now let's say ax and then plus b, by and then plus cz, so equals, so maybe d. A, b, c, and d are numbers. Okay. Or you can say given the a plane in general form, the equation is in general form. It doesn't matter. Okay. Of course, a, b, and c are not all zeros. The only restriction is that a, b, and c are not all zeros. Okay. If you have an equation of the plane, and then it's easy to identify a vector normal to the plane. And then, so do you want to guess a vector normal to the plane? If you are given the equation of a plane, I'm looking for the three components. Okay. I'm looking. Then I will tell you the conclusion. Okay. So now let's say n. I'm going to use n to denote a vector normal to the plane. The vector, as long when looking for a vector, when telling me a vector, you have to tell me the three components of the vector, right? And then n, from n, the vector n with three components. So now let's say a, b, and c. A is coming from the coefficient of x, b is coming from the coefficient of y, c is the coefficient of z. Okay. So by that we mean the the vector with 3 coefficients as the components is a vector normal to the plane. Okay. After knowing that, we are ready to do some handout questions, I believe. Okay. Now let's work on part 5, question 1. Part 5, question 1. Okay. Okay, so before we do the question, now try to understand the following. Okay, try to understand the following. How do you describe if I'm telling you two planes? If two planes are parallel, how do you want to tell me the normal vectors of the two planes? Now try to understand the following. Two planes are parallel if and only if they have the same normal vectors. So does that make sense? A normal vector is a vector perpendicular to the plane. If two planes they share the same normal vectors, the two planes have to be parallel, right? The other way is also true. Okay. If two planes they have the same normal vectors, they have to parallel. They have to be parallel, right? So does that make sense? After you know that, then we are ready to work on the question. Solution. Now look at the thing. Okay. Now we are looking for the equation of a plane parallel to the other plane and passing through a point. Now let's recall, to get the equation of the plane, we need two things. We need two pieces of information. We need a point. You are given a point. You can take that point. Okay. And how do you get a normal vector? So what is a normal vector to the plane we are looking for? So because the plane we are looking for is parallel to that plane, now look at the cursor. They share the same normal vector, right? You know a normal vector to that plane, right? So you can get a normal vector. Okay. Okay. Now the solution. The required plane the plane we are looking for is the required plane. Okay, the required plane. So maybe passes through a point. That's a given information. We need one other piece of the information. We need a normal vector. Okay. Again, so because the plane we are looking for is parallel to that plane, they share a normal vector. Okay. I'm going to write one more sentence. Okay. Since the required plane is parallel to that plane, the plane has the equation of x plus y and then plus z equals 1. Okay. So the required plane, a little bit wordy, but I'm trying to make it clear. Okay. The required plane has a normal vector Anybody want to tell me a normal vector of the required plane? Please. I'm going to use n to denote the normal vector, so just tell me the three components, please. This plane has a normal vector 1, 1, 1, so the required plane, the plane we are looking for, is parallel to that plane, right? So they share the same normal vector. So a normal vector is the vector with three components 1, 1, and 1, right? So does that make sense? Now we have the two things we need to get the equation of the plane. We have a point, we have a normal vector. Okay. So maybe therefore the equation of the required plane okay, you have a point, you have a normal vector, you have a times x minus x0, right? You have 1 times x minus 1, and then plus 1 times x minus 2, and then you plus 1 times z minus 3 equals 0. Okay. Again, in the formula you need a, b, and c, you need x naught, y naught, z naught. A value is 1, b value is 1, c value is 1, x naught value is 1, y naught value is 2, z naught value is 3. Okay. Again, you do not have to write the equation in any other form, so this form is perfectly okay as the final answer. Another simple question. It's pretty straightforward, I think. Okay, now we're going to do a few more questions. Okay, if you are given 3 points on the plane, how can we determine the plane? Actually, there's a joke saying something like, can you try to answer my question? Okay, when are 3 birds in the sky on the same plane? When are in the sky you have 3 birds? When are the 3 birds on the same plane? So please try to tell me the answer, please. When are 3 birds in the sky on the same plane? When, please. Can you hear me? When are at what time or when? They are always on the same plane. They are always on the same plane. So that makes sense. 3 points can determine a plane. They are always on the same plane. I did not say a horizontal plane. They are always on the same plane, right? I don't have too much time to make too many jokes, actually. Now my point is that 3 points can determine a plane. 3 points can determine a plane. So that makes sense. In the space, wherever you have 3 points, and as long as the 3 points are not on the same line, the 3 points can determine a plane. Can uniquely determine a plane. The condition is that 3 points are not on the same line. Okay. So that will make sense. How to get the equation of the plane passing through 3 points. As long as you have 3 points, then 3 points can determine a plane uniquely. Okay, so it makes sense to get the equation of the plane. Okay. We'll work on the questions one by one. Actually, the questions are not okay. How about that? I'll copy the entire question. On the midterm, I'm pretty sure you're going to see a question like, you're given 3 points. I'm looking for the equation of the plane. Something like this. We'll work on question A first. Okay, now the solution to question A. So don't be confused. Don't be confused. We need to to get the equation of the plane. We need two things, right? We need two pieces of information. We need a point on the plane. We need a vector perpendicular to the plane. Now you imagine in 3D. We're working on question A. Okay. I don't care how the 3 points are located. Okay, say that point is P1. Actually, I'm going to call the first point P1 so that it's easier for me to use notations. Okay, I will use P1 to denote the first point, so which is the point with x coordinate of 1, y coordinate of 2, and z coordinate of 1. Okay, and I'm going to use P2 to denote the second point, 2, 1, 0. I'm going to use P3 to denote the third point, 1, 2, 0. Okay, now let's say P1 is here. Now let's say P2 is here, wherever P2 is. Now let's say P3 is here. Okay. Again, as, the 3 points are not on this plane. You imagine 3 points in the sky, in the space. Okay. Again, to get the equation of a plane, we need two things. We need a point, and we need the other thing we need. So you are given 3 points, right? You can use any of the 3 points as a given point. Now try to recall the formula. Okay. The other thing we need is a vector perpendicular to the plane. You are given 3 points. How can we get a vector perpendicular to the plane? Passing through 2 points P1, P2, you have a vector. The vector with the initial point of P1 and the terminal point of P2, right? The other vector is a point with the initial point of P1 and terminal point of P3. So of course, the choice of the two vectors are different. Okay, so could be different. Okay, so you have another vector, P1, P3. Now listen to me carefully. Now we are looking for a vector perpendicular to the plane. You kind of have two vectors on the plane, right? You kind of have two vectors on the plane. The plane is the plane determined by 3 points. You have a vector P1, P2. You have a vector P1, P3. You kind of have two vectors on the plane. Now I'm looking for a vector perpendicular to the plane. Anybody want to tell me how to use these two vectors P1, P2 and P1, P3 to get a vector perpendicular to the plane using something we learned before? So please, I'm looking for a term. Anybody? You know that. Which vector is perpendicular to the plane? Performing what operation on P1, P2, P1, P3, you can get a vector perpendicular to the plane? Recall some property we learned last time. What is resultant vector? So tell me a term. I'm looking for operation, please. What operation do you want to perform on the two vectors so that the vector is perpendicular to the plane? What is the direction of the cross product? Cross product of P1, P2, P1, P3 is a vector perpendicular to the plane. You learned before? We just mentioned the last week. Okay, so not a long time ago. Okay. I'm using P1, P2, P3 to denote the given 3 points. Okay, now I'm looking for a vector perpendicular to the plane. So maybe we let n be. So now let's say P1, P2. That's a vector, right? And then, so before that, yeah, probably I want to compute P1, P2, and P1. Okay, I'm going to get the components of the two vectors first. Okay, and then the vector with the initial point of P1, terminal point of P2 is equal to, for this vector we need to get the three components of the vector. I think we did the question too many times already. Okay, the first component is computed using the difference between x coordinate of P2 and the x coordinate of P1. I'm going to write that in some more detail. Okay, the first component is 2 minus 1. The second component is 1 minus 2, right? Third component is 0 minus 1. I think you know how these numbers are coming from. Okay. So the first component is 1, the second component is negative 1, the third component is also negative 1, right? That's P1, P2. You also need to get the three components of P1, P3. Now let's say P1, P3. That's the vector with two initial point of P1, terminal point of P3. Now you look at P1, P3. So correct me if you see anything wrong. Okay. Now look at P1, P3. The difference between two x coordinates is 1 minus 1. And then 2 minus 2. Did I copy something wrong? Yeah, I think that's right. I'm looking for P1, P3. 0 minus 1. So, which means the three components of P1, P3 has the first component of 0, the second component of 0, third component of negative 1. Okay. Now, in order to get a vector perpendicular normal to the plane, we need to compute the cross product of the vectors. Okay. So can I also say we let n be the cross product of P1, P2 and P1, P3. Then intuitively you see n is a normal vector. A normal vector to the plane. Okay. Now I want you to take a few moments, okay, to get me the cross product. Okay. Now let's compute the cross product. So the vector n. So do not forget the formula. Actually, everything is going to be open book. You do not have to memorize the formula. But for the formula for computing the normal vector is ijk, right? In the first row. And the second row you have the components of P1, P2, so which is 1, negative 1, negative 1, right? And then the third components, the third row has the components of 0, 0, negative 1, has all the components in P1, P3, right? So please, now I'm looking for the final answer to this. Okay. In most cases, you have to use the first row so that it's easier to compute the components. Okay. So because we did this last week, I'm going to show you how this thing will work. Okay. The number before the vector I is the 2 by 2 determinant. You remove the first row and the first column. I think the 2 by 2 determinant you have -1, -1, 0, -1, right? That's the coefficient before I. And then the number before j, the coefficient before j, the sign here should be negative. I think on Friday you did a few questions. You did at least, so not at least one. You computed three things, right? I asked you to verify identity involving three products, three cross products. Okay. So negative sign here, and then you remove the first row, the second column. I think the 2 by 2 determinant you are going to get is 1, -1, and then 0, -1. The next term, the sign is positive, and then you have k in here, right? The 2 by 2 determinant, I believe, is 1, -1, and 0, 0. Now it's easy to get the final answer. I think the first component is 1, is that right? The coefficient of I think you have -1 times -1, so minus 0. So you have 1. The second component, please, is also 1, right? Third component is 0. So can anybody double check the answer for me? Can anybody confirm I have the final answer right? Most likely is right. Sure, thank you. Thank you very much. Okay, now we have everything we need. Again, I want you to recall the formula. To get the equation of a plane, we need two things. We need a point on the plane. In this case, you are given 3 points. You can take any point as the given point. Okay, any point is fine. And then we got a vector normal to the plane. Now we are ready to have the equation of the plane. Okay. So can I write the final answer in here? I don't want to start a new slide because I want to leave everything on the same slide. Okay, finally we are ready to have the answer. Whichever point you want to use. So can we use P1? Okay. So A value would be 1. X0, X0 value would also be 1. Okay. So the equation of the line would be something like this. 1 times x minus 1, right? Again, in the formula you have a times x minus x0. A value is 1, x0 value is 1. Okay. And then the second term, I believe you have y minus 1, y minus 2 actually. Okay. So it's 0, right? Again, for this one, you do not have to convert the equation in any other form. Okay. So that's the answer. Okay. Any questions about this? The bottom line is to try to memorize the formula, and then you do need to know what you need in the formula. To get the equation of any plane, you need a point. You need a vector perpendicular to the plane, a normal vector. Okay, as long as you can have the two things, you can get the equation of the plane. For questions, if you are given 3 points, you are looking for the equation. Okay, 3 points can determine a normal vector by computing a cross product. Okay, so that you can. So that's the idea. Now we work on question B. Okay, we now work on question B. It's probably I'm not 100% sure yet. I'm not going to say it. I'm trying to say it's likely on Friday you're not going to have a quiz. I'm also trying to say the next question. Okay, should I use in-class quiz? It's not in-class quiz. It's okay. Okay, I'm going to ask you to try a question at least. I want you to try B. Okay, and then we compare the answers. Now try question B, please. Try question B. I will get you started. Okay. We introduce some notations first for question B. We let so maybe P1 for the first point. Okay. The point with x coordinate of 1, y coordinate of 0, z coordinate of 2. Okay. And then P2 is the point 1, 1, 0. And the P3 to the point with x coordinate of 2, 2, 0, 1, right? Y coordinate 0 and then z coordinate of 1. Okay. Actually, for the midterm, I was trying to make some comments earlier. I forgot earlier. In particular, for the people who have never taken courses with me, your midterm is going to have multiple versions. You have to do your own version. If you do another person's version, you're going to get 0. I'm trying to say, so before you open the exam, you do not know which version you have. You have to work on your own version. After a little while, I kind of know who's friends. I can tell from the assignments or whatever thing. So for you and your friends, so most likely you are going to have two different versions. I'm trying to say. Okay, and then I want you to work on this question. Okay. Yeah, probably you want to compute P1, P2. So get me the three components of P1, P2, and get me the three components of P1, P3. You're kind of getting all the question marks for me, okay? And then you'll say something like the vector n, so which is the cross product of the two vectors. So please try to get me the cross product. The cross product of two vectors is a vector, right? It has three components. After getting a normal vector, then you are ready to get the equation of the plane. I will give you a few minutes to work out this one yourself. Okay. It's nothing difficult. We're working on question B. Okay. Again, your choice of the vectors you use to get the cross product may not be unique. You could also use P2, P1, P2, P3, and so on. As long as you use two vectors not on the same line, it's fine. Okay. Anybody want to tell me the components of a normal vector, please? If we use P1, P2, P1, P3, so just tell me the three components in order, please. Anybody? Anybody? -1, -2. I need one other person to tell me the answer. I see two different numbers. I think the first and third components are mostly right. Most likely right, I mean. First component is 91. The second component, the third component is 0, right? I'm looking for the second component, please. I need one other person to tell me the second component, please. So please.
Sorry, I made a mistake. It is -2.
Okay, it's -2. Sure. Yeah, probably the sign associated with the second term is negative. That's probably something. So we have a normal vector to the plane. Now, after getting a normal vector, then you are ready to get the equation of the plane, right? The equation of the plane, use -1 as A, -2 as B, right? How about we just use P1? We just use P1, okay? It's -1 times, now let's say x minus 1, and then -2. -2 is the B value, right? And then y minus 0, -2y is equal to 0. You do not have to convert the equation to any other form, so that form is perfectly okay as the final answer. Okay. So we're done. We're done question 2. After doing 2 questions, I believe you can do question C without any problems. Okay. Anybody have any questions?
Shouldn't it be x minus 1, not x minus 0?
Yeah, x minus 1. So sorry about that. If I was using the first point, it would be this. So thank you. No, I think it's okay. Can skip I'm going to skip question C. Okay. I believe as long as you know how to do question A and B, C should be simple too. Okay. Again, on the midterm, you are going to see a question like this. You are given 3 points. You are looking to find the equation of a point. Using a question like that, I can check the cross product. I can check the equation of a plane and some other things, right? Okay, if you don't have any questions, then we move on to the next topic. Equation of a line. In the space, we can also talk about a line, right? When are two verses on the same line? Two verses are always on the same line. I'm trying to say 2 points can determine a line. Okay. Actually, in the equation, in the conclusion, the theorem on the screen, the 2 pieces of the information we need is a point, and it's also a vector parallel to the line. We call it a direction vector. Okay, you imagine in space. You imagine in the space. In the space, okay. You imagine if you have a point in the space. Imagine that point is in space. Imagine everything in 3D. Okay. You have a point in the space. So now let's say the point has x coordinate of x naught, y coordinate of y naught, a number, right? Z coordinate of z naught. You have a point on the line in the space. I mean, okay. If you have a vector in any direction, So now let's say the vector is L. Okay. A vector L has three components. So now let's say A, B, and C. These two pieces of information can uniquely determine a line, right? The line is the line passing through this point and parallel to line L, or in the same direction as line L. A line can have two directions. So can I just say parallel to the line? Okay. Again, the point is on the line, and the line is also parallel to the vector L. Okay. I was trying to say these two pieces of information can uniquely determine a line. The line is something like this. Imagine the thing in space. Okay. Now we're trying to get the equation of the line. Okay. The equation of the line. A line cannot be determined by one equation of three unknowns anyway, right? One equation of three unknowns. A equation of one equation of three unknowns is a plane. Okay. The equation of the line has two forms. So temporarily you just memorize the two forms. If we have time, we can talk about the y. Okay. But memorize the equation. Okay. The first form is called the vector equation form. The second form is called the parametric form. Again, I want to repeat, the first form has a name. It's called the vector form of the equation of a line. The second form is the parametric form, or the parametric equations of a line. I will make more comments later, but I was trying to say vector form and the parametric form. The two forms are equivalent. By equivalent, I mean it's very possible to convert from one form to the other form. Okay, to help you memorize, I'm going to write the equation here. Okay. The vector form is something like this. The vector form is, on the left hand side you have x, y, z. X, y, z is actually coming from an arbitrary point. But let's say, can I call this point P0? I'm going to say an arbitrary point P on the line has x coordinate of x, y coordinate of y, z coordinate of z. Okay. So that makes sense. X, y, and z are variables. It depends on the location of P. For different location of P on the line, the values of x, y, and z are different, right? So there are variables. Okay, a point P can determine a position vector with the first component of P, the second component of the first component of x, second component of y, third component of z, right? Okay, now the vector equation is the following. Okay. Now look at here. Okay. And then plus t, we call it t is actually a parameter. A parameter can take any value. I'm going to make more comments soon. Okay. T times the three components of the direction vector. Again, so this L is called a direction vector. I think you have A, B, and C in here. Okay. And then equivalently, you compute two sides of the equation. Each side is a vector, and the two vectors are equal if and only if they have the same components. Okay. And then you compare the components of two sides of the equation. You have three equations. That's why we call them the parametric equations of a line. Okay. So don't worry, everything is going to be very clear very soon. Okay. You compare the corresponding components. X equals, now look at this, x0 and then plus at, right? Y equals, now let's say y0 and then plus bt, and then z equals z0 and then plus ct. Okay, to make the whole thing so clear, I'm going to use a particular question to show you the meaning, and then I'm going to make more comments saying why there's a parameter t involved in the equations. Okay. I will see if I have a handy question on the handout. Okay, now look at the question 1. That's a simple question, a straightforward question. Okay. After doing this, I'm going to make more comments. In the question, we are looking for the equation of a line in both forms, passing through a point, and have a direction vector L. Okay. We're going to use the notations consistent with the notations in the formula. Okay. So by that we mean this is a point. A point has three coordinates. X naught value is 3, right? 3 is x naught value. Y naught value is 0. Z naught value is 0 if you look at the formula. Now you look at the formula. We use x naught, y naught, z naught to denote a point, a known point, a given point on the line. And then we are trying to use ABC to denote the three components of the direction vector. So A value is 1, right? You just put some notes in here. B value is -7, C value is -3, right? Now we are ready to write the equations, right? To write the two forms, either form, the vector form and the parametric form. Okay. Probably it's easier to memorize the vector form. Okay. The vector form of the line. The vector form of the line is the following. Okay. X, Y, and Z are three unknowns, three arbitrary unknowns. You imagine X, Y, and Z represents an arbitrary point on the line. Okay. Is equal to, in this case, x naught value is 3. So I think you have 3, 0, 0 in here, right? And then plus t times, I will show you what's going on very shortly. Okay. 1, -7, and then -3. If you look at the formula on PDF, I just replace all the numbers x0, y0, z0, a, b, and c, so with some given numbers. Okay. Try to memorize the vector form, and then it's easy to convert the vector form to parametric form. Okay. The parametric form, alternative way to say the parametric form, we can say the parametric equations of the line. So there are three equations. So do not say the parametric equation. Say parametric equations of the line. Okay, the parametric equations of the line. Parametric equations. Actually, for the people who are in calculus, you are going to see parametric equations of curves in space on the plane actually. So very shortly after the midterm, I'm going to make comments on Math 102 midterm this afternoon. Okay. You compare two sides of the equation. I think you have x equals 3 and then plus t, right? You imagine you perform vector addition and scalar multiplication, okay, and then you compare the components. You have x equals 3 plus t and y equals negative 7t, okay, and z equals, I think you have negative 3t. In both cases, if you want, it's better to write something, okay? You say t is a parameter. Okay, now listen to me carefully. I'm going to make some comments on this, why we call it a equation of a line. You just remember one thing. Now I want you to remember one thing. T is a parameter. It means t can take any values. T can take any real number values. Now you remember one thing, probably a slogan. Remember a slogan I'm telling you right now. Okay. Each value of t determines a point on the line. T can take any value. T can take any real number value. So t can take many values. So many values of t can determine many points. So many points will form a line. In general, will form a curve. That curve in this particular case is a line. Okay. I'm going to make my points more clear. Okay. Probably I'm going to include some questions like the following on the midterm. So maybe tell me a point on the line corresponding to t value of 0. So tell me a point determined by t value of 0. Determined by the following is not a solution to the question, so we're done the solution. Now I'm trying to use some questions to help you understand the meaning of the equation. Okay. If we set t value of 0, t value of 0 will determine a point. T value of 0 will give you what point? I'm looking for a point determined by t value of 0. T value of 0 will give you x value of 3, right? Y value of negative 7, and z value of negative 3. You plug t value of 0 into 3 equations. You have x value of 3, y value of negative 7, and z value of negative 3, right? Now let's try to get one other point. Okay. Now let's get the point for t value of maybe 1. Anybody want to tell me very quickly in the chat? What is the point on the line determined by t value of 1? Please. What is the point determined by t value of 1? Sorry, I think I did something wrong. T value of 0. Something went horribly wrong. T value of 0 determines a point 300, right? I'm going to correct this. T value of 0 determines a point on the line with x coordinate of 3 and y coordinate of 0 and z coordinate of 0. and t value of 1 determines 4, negative 3, 4, negative 7, negative 3. Hardly told me, and Ben told me too, I think. 4, negative 7, negative 3, right? And this list can go forever. This list can go over and over forever. Okay, again, t can take many values. You have the choice of 0, you have the choice of 1. Actually, t can take any number, right? Many values of t will determine many points in space using the parametric equations, right? And many points in general form a curve. In this particular case, from a straight line in space. That's why we call it the equations of the line, right? If you know the parametric forms and know the parametric form is equivalent to the vector form, then you should know everything is okay, right? They're equivalent. Again, another straightforward question designed to illustrate the meaning of the notations, the formula, I mean. You know in space, 2 points can determine a line as well, okay? Now let's work on question 2, and then we'll have more than enough time to do question 2, okay? Now I'm kind of confident on Wednesday I can start to do some review, okay? On Wednesday we are going to finish the new stuff and then we'll do some review. I'm trying to say on Friday you probably still have a quiz if I can finish the review. Okay, now look at question 2. In question 2 we are looking for, if you are given 2 points, we are looking for the equation of a line in 2 forms. It's not hard to imagine in space 2 points can determine a line, right? There's a unique line passing through the 2 points. Now, so don't be confused, okay? To get the equation of the line in either form, we need 2 things. We need 2 pieces of information. We need a point. We can use any of the 2 points as a point. What's one other thing do we need? A vector parallel to the line, or in the same direction as the line. Any vector can we take as a vector? Can we take as a direction vector? So tell me 2 letters, please. And which vector can we take as a direction vector? So does that make sense? P1, P2 is a direction vector. It's in the same direction as the line. It's on the line. It's on the line. It's kind of parallel, right? Okay. Now we're computing the vector P1, P2 in terms of 3 components. So this one is super easy to compute. First component is coming from 4 minus 3. The second component is coming from negative 7 minus 0. Third component is negative 3 minus 0. You'll have a formula for computing the components of a vector if you know initial and terminal points. So this vector has 3 components. So maybe 1, negative 7, right? Is it converted to the... So it doesn't matter. We'll redo it.
That bottom number should be negative 3, not negative 7.
Yes, sir. Negative 7 and then negative 3, right? So do you see the question is actually converted to the first problem? We'll complete the solution anyway, okay? Okay. Try to understand why P1, P2 can be a direction vector. That's actually a vector in the same direction as the line, right? A vector parallel to the line, okay? In this particular case, the term parallel is kind of the vector can be can be on the line. Okay, now we are ready to get the forms of to get the vector equation of the line, to get the parametric form of the equation of the line, the parametric equations of the line. Okay, so the vector equation. So we'll do it again. Actually, we just did it, right? On the left hand side, you have x, y, z. You treat that thing as a vector. X, y, and z are coordinates of an arbitrary point on the line. Okay. So here you have x naught, y naught, z naught. I think you can use any of the 2 points as x naught, y naught, z naught. Okay. Can we just still use 3, 0, 0? It's the same thing, right? And then plus a parameter t. So do not forget the parameter. Okay. Parameter t, and then times ABC. ABC are the components of the direction vector you chose. That's the vector equation of the line, or vector form of the equation of the line. Now the parametric equations of the line. The same as before. I think we have seen this already. Okay. X equals 3 plus t. Y equals, I think you know where the numbers are from. Y equals negative 7t, right? Z equals negative 3t. Again, probably it's more important to understand why these two forms represent an equation of a line, right? Say something like t is a parameter. T is a parameter.